Just thought I'd start with a Dilbert cartoon. I don't know how to do statistics, but it doesn't matter because I didn't have data. So we're doing confidence intervals when we know the standard deviation population. That's today's lesson. So what are confidence intervals? Well, when we take a sample or a survey, we're usually trying to predict the mean of the population. That's the whole point. We could calculate the mean with a census, but it's very difficult to do censuses. So instead, we're going to use the mean from our sample. Now, if I got an average of 17 from a sample, I don't know, 17 whatever, does that mean that my population average is 17? No, it doesn't, because there's randomness in my measurement. For example, if I was to say the average age of students in my statistics class and I got 17 and I was trying to say that would be fine if I measured everybody and got the true average. But if I just picked a couple people and took a guess, that's no guarantee that the average age is actually 17. So let's say I was only able to take a sample and I wanted to make a prediction of the average age. Well, actually, I'd feel more comfortable using a window. I'd say, oh, somewhere between 16 and a half and 17 and a half, or 16 and 18, which actually would be pretty safe, big window for my class. So if it is normally distributed, if our population is normally distributed and we know the standard deviation, then we know what percentage of the data should fall within different windows. Each half of our window is called the margin of error, and we have a name for our window. We call it a confidence interval. Now, the width of our window depends on how confident we want to be. That depends on something we're going to need to calculate, a critical value, which we call z star. So you've been calculating z's from that z equals x minus mu over sigma formula, but now we're going to determine z's depending on how confident we want to be. So recall the empirical rule, 68% of the population lies within one standard deviation. So in that case, z star would be, or the critical value would be 1. For 95%, that's within 2. Now I'm going to be a little more exact. It's actually 1.96. And for 99.7% of the population, they lie within 3 standard deviations, and I would use z equals 3. Now, so I could be 68% confident, 95% confident, 99.7% confident. What if I wanted to be 100% confident? Why don't we just use 100% confidence intervals? Well, I could say that the average age of all my students in my statistics class is between 6 and 25, and I would be 100% confident. Or I could pick more realistic numbers. Probably closer to 14 to 19 is what I would guess. But are you very impressed with my prediction? No, because I had to use the entire range of possible values. So let's look at the next example. How many standard deviations from the mean do I want to go if I want to be 90% confident? Well, z star should be somewhere between 1 and 2 because I want the middle 90%. Well, how much does that leave for the other two pieces? Well, they have to be the same size. There's 10% left. So there's 5% in front and 5% in back. I personally, working with you now, I see it's a lot easier if you do your z-score for this side and include this whole area. So use the left area here to determine z star. Well, when I put these two together, I'm going to get 0.95. Now remember, this is a decimal here. We're going to do inverse norm of 0.95, and I get 1.64. So I want to be 1.64 standard deviations away from the mean on either side if I want to be 90% confident. What about 99% confident? Well, I'm going to guess z is going to be somewhere between 2 and 3 for that. So there's my 99%. That leaves me 1% for the outside tails. So I'll put 0.5% here and 0.5% there. Still using the left area. So I'm going to do inverse norm of 0.995 because this is going to be 99.5%. Move the decimal over 2 places and you get 0.995. All right, so now I know how to do z-stars, right? We know how to find critical values. What's the next bit? We have to determine the width of our windows, and we remember that's the margin of error. So the formula for that is z star, which we just showed you how to get, and sigma of x bar. Sigma from that we have based on our sample. So, or for our population. So I'm going to look at this example, the average weight of 100 shrews. This is a lot like one of your problems on your WebAssign, except it's hummingbirds instead of shrews, and the numbers are a little different. Well, the average weight of 100 shrews. So it's important to know a couple things. This is my N, here's my average, here's my sigma, and there's my confidence level. So I'm going to be using all of these to determine my window. What critical value do we want? Well, we want 95%. So if you recall, 95% was in here, right? And that meant that I had 2.5% here and 2.5% on the right. Therefore, my critical value actually would be the inverse norm of 0.975, and we did that earlier, and I get 1.96. So what standard deviation should we use? Well, I have a formula, sigma of x bar. We're going to use that. It's my population standard deviation divided by square root of n. Remember, for averages, our spread is tighter, and I end up getting 0.008. See, the n is 100. It comes from up here, 100 shrews. 0.08 comes from the sigma they gave me here. So for my margin of error, I'm going to use the formula that we just did, which is a critical value times standard deviation. So 1.96 times 0.008 is 0.01568. Pretty big. I mean, well, pretty small, but a lot of digits. All right. So now we're going to go ahead and actually find the window. We're going to set a lower limit and an upper limit. The lower limit is going to be my average minus the width of the window. In this case, 5.45 minus that margin of error, and roughly 5.43. My upper limit, same idea. I just add the margin of error, the width of the window, the half width of the window, really. And I get 5.47. So I now have a 95% confidence interval that the average weight of shrews is somewhere between 5.43 and 5.47 grams. So what does a 95% confidence interval really mean? Well, basically, intervals, don't forget, they have the form which is your estimate or your average, plus or minus your margin of error. So you can see there are a bunch of different confidence intervals. Our process is in constructing the interval, not in any actually one interval. You can see some of these intervals, we miss the true average. This green bar right here, which I'll highlight, that represents the average. And it does, not all the intervals contain it. But we're confident that 95% of the time we will capture that guy. So in 95% confidence interval, we expect to capture, in 95% of confidence intervals, we expect to capture the population parameter. Now you are expected to interpret the results. So I'll show you two different ways to do it. They're very similar. One way you can write this is there's a 95% chance that the interval is one of the intervals that contains the true average weight of shrews. Another way you can write it is 95% of the confidence interval created using this method will contain the true average weight of shrews. Pretty much saying the same